Welcome to Lesson 112 of Saxon Math Course 2. You're going to want a calculator for this video, so please make sure you have one. We're going to use the Pythagorean theorem to solve real-world problems, show you why we learn it, and we're going to identify Pythagorean triplets. Alright, we have no new vocabulary, so let's dig right in. So first of all, let's talk about what a Pythagorean triplet is. That is consecutive numbers, not necessarily consecutive numbers, but sets of numbers that all form a perfect right angle. So when workers are building a building, for example, if they've got a building that's going to be 40 feet long, and they're, instead of having a 90-degree angle, if they have an 89-degree angle or a 91-degree angle, when they get to the end where the walls are supposed to meet, they're going to be 8 inches apart, which is a major problem. So that's why it's important that construction workers check whether their building under construction is square by using the Pythagorean triplet. By doing that, and I'll show you how they'll do that on the next slide. But triplets are like 3, 4, 5, and any multiples of those. So you take 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. That's right here. So there's another triplet. And then 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. There's another triplet. 3 times 4 is 12, 4 times 4 is 16, and 5 times 4 is 20. So there's another triplet. Those are all Pythagorean triplets. So this is what they do. When they go out there and they check, they're going to pour their foundation. They put in the wood in the ground. You've probably seen this, like they're pouring sidewalks and stuff. You've seen this. They have wood, and they build these frames, and then they pour the cement in. But before they do that, they want to make sure that they're perfectly square. So what they're going to do is they're going to take on this board right here, and they're going to measure 4 feet or 4 inches. It wouldn't matter either way. But 4 feet, and this one here, they're going to measure 3 feet. That's our 3 and our 4. And then they're going to measure the inside here to see if it's a 5. If it's a 5, they know that that's a square, because 3 times 3 is 9 plus 16, which is our 4 squared. 3 squared, a squared plus b, a squared plus b squared equals c squared, which is 25. And that works, doesn't it? And those all break back down to 3, 4, and 5. So they know that that's a perfect square. So we're going to look at some of these. They're going to be kind of tough to figure, but you wanted to know how we're going to use it in real life, you're going to see, and you're going to appreciate it more now. So the numbers 5, 12, and 13 are also a triplet, because 5 squared plus 12 squared, that's 25 plus 144 equals 169. So 5, 12, and 13 all works perfect. They're a Pythagorean triplet. So what would be the next 3 sets, starting with 5, 12, 13, what would be the next 3 sets that are also triplets? And you can find that by multiplying each number by 2, 3, and 4. And if you were to do that, 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26. That would be your first set, right? And then you'd do the other 3 also. Okay, so you should have come up with these 3 sets right here. And this one here you're multiplying by 2, this one here you multiplied by 3, and this one here you multiplied by 4. All right, so now let's put this to use. So let's take a look at this, because this can be a little bit tough. All right, so we got a roof, and it's being built over a 24-foot wide room. The slope in the roof is 4 and 12, meaning that for every time it goes over 4, it goes up 1. So calculate the length of the rafters for the roof, including the 2-foot rafter tail. So that's a lot to do, but we've got it right here. We've kind of got it. They've drawn it 4, so that's going to help us a lot. Here's our rafter tail. So that's 2 feet. So we're going to go here and put our 2 feet over here. We know we're going to have plus 2 feet in our answer, because we got it, because it asks for that. It says to include 2 feet right here. So now let's just figure out. I'm going to split this right down the middle, and if you split down the middle, we know that half of that is 12, and that's our 12 right there. And then by knowing that it's 4 and 12, we know that it's 4 tall. So by looking at the width of the room is 24 feet. The rafter spans only half the width of the room, so the base of the triangle is 12 feet. We've got that. And the slope of the roof is 4 and 12, meaning that for every 12 units that we move horizontally, every 12 units we go sideways, the slope of the roof falls 4, or rises. It goes up 4 vertical units. So that's the 4 and the 12. So we've got our 2 numbers, the 4 and our 12. So we're going to go ahead and use the Pythagorean theorem. A squared plus b squared equals c squared. We know that our hypotenuse right here is always the c. So 4 squared is going to be 16, and our 12 squared is going to be 144. equals our c squared. Okay, so we got to solve for our c squared. So 16 times 144 is 150. Well, is 150 or 160? I'm sorry, 160. Is 160 a perfect square? It's not. But if you pop it in your calculator, you're going to get 12.65 feet. So we know that this distance right here is 12.65 feet. But we've got to add this extra 2 feet right here. So our answer is going to be 14.65 feet. But what does 0.65 feet equal? How many inches is that? How do you do that? Well, the way you do that is you're going to take your 0.65 feet and you're going to use a unit multiplier and you're going to convert it to inches. So you can take 0.65 times 12 and you're going to end up with 7.8 inches. So we're going to round that up to 8 inches. So we know that our answer here is going to be our 12 plus the 2 feet is 14 plus our 8 inches here. So we end up with 14 feet 8 inches. Pretty tough, I know. But if you take it one step at a time, you can do it. Let's look at another one. Okay, here we've got Shireen, and she's gone out in the field, fly a kite. I love to fly kites. I hope you get a chance to do, and if you haven't done it in your lifetime, you need to go out and do it. She's let out all of her 200 feet of string and tied it to a stake. So then she's walked out into the field until she's directly underneath the kite, and she measured as she walked, and she knows that's 150 feet. So she's flown her kite clear up here, 200 feet, and then she's walked out here 100 feet, and now she wants to find out how high up her kite is in the sky. So she's going to use the Pythagorean theorem to do that. So see if you can solve this. Go ahead and fill in the blanks here. Pause it and see what you can do. Remember that the hypotenuse is always your c. This is always your c squared. So you're going to have a squared or b squared, whatever you want it to be. And this is going to be your b. This is going to be your c. Pause it and see if you can do it. Okay? All right, so let's do it together. Okay, so you've got 150 feet squared. We know that. 150 feet squared plus b squared equals the 200 feet squared, which is our c. All right, so that's what we got to know. So here we've got, this works out to be 200 or 22,500. And this one here over here ends up being 40,000. So when I subtract the two of those, I get 17,500 right here. And this is the one I've got to square. And once I square that, I'll know how high her kite is up in the air. And when you put that in a calculator, you pop that in a calculator, you're going to get that she's approximately she's 132.3 feet in the air. Approximately, it's approximate because of all the decimal points. So approximately 132 feet. All right, we're using bigger numbers. That's why I told you to bring a calculator. But there you go. You could have done it with 15 and 20 and then added the zeros later. But there you go. Let's try it. Let's see if we can do it again. Okay, and this one here, this is a little bit different type problem. Here you've got, let's say we've got our soccer field out here, and our soccer field is 300 by 400. And someone says that they're going to run across the field here and then up here. How long is that going to take them? They want to know how much shorter it's going to be to just cut across like this. Okay, so the path from A to C, they want to know the path from A to C is how much shorter than it is if they go the long way like this. So you got to use the Pythagorean theorem. All right. So let's go ahead and do that. Let's drop the zeros to make this just a little bit easier. And your triplets should also help you here too. So what we've got here, if we drop our zeros, is we have a 4 here and a 3 here. So 3 times 3 is 9, 4 times 4 is 16, and add those together, it's going to equal 25. And when we get the square of all those, we know this is going to be a 5. But then we got to add our 2 zeros back in, right? So this is really 500 feet. So to go kitty corner, that's 500 feet. To go the long way, so that's going to be 300 plus 400. So that's going to be 700. So the distance, the A to C is shorter by 200 feet. Hopefully that just makes a ton of sense and it starts to click with you. I hope so. If not, bring your questions. We'll discuss it tomorrow in class. Here's your TIDs. Do number 8, 17, 26. Send them to me tonight. And we'll work on lesson 112 in class tomorrow as a group or individually. Thank you for watching the video. See you tomorrow.